Okay, good. I'll take that as a yes.
Well, here in Sierra Madre, I've gone over 37 inches of rain so far this winter, which is pretty good, you know. And downtown LA is almost 26 inches of rain in the 145 years of record keeping. This will definitely be in the top 10 before we're done here.
Wow.
Okay, well, I think we have a quorum here. I'd like to welcome everybody. For those of you who don't know me, which I don't think there's anybody on here who doesn't, but maybe. I'm Kim Schreiner. I'm the founder and president of the board of the Phil Simon Clinic Tanzania Project. And I'm delighted that you've chosen to join us tonight. We have a very special guest who has incredible powers of B because he was able to conjure up all kinds of ambiance for us today, including tornadoes and water spouts and torrential rain, hail, snow, and all kinds of goodies. And he's going to explain a little bit about some of that tonight for us. So we're really honored to have Dr. Patzert, and I'll introduce him more formally in a second. I'd like to make sure that all of you remain on your, please mute. And I think going forward, we're going to ask that everyone actually turn their cameras off. That way we spare you any embarrassment if you happen to take your phone and computer into the bathroom or something during our presentation and it creates a distraction. So I'll ask everybody except for Dr. Patzert and myself to turn their, I'll turn my camera off when I'm stopped yammering here, but if people could turn their cameras off, that would be good. We will have a little bit of time at the end for some questions. I just want to kind of make a couple announcements. In addition to having a very distinguished NASA oceanographer, engineer, and climatologist with us tonight, he's going to set the stage for our next guest in April, which will be Dr. Jane Goodall. That'll be Wednesday, April 12th. Same sort of arrangement where you can you can go on our website, www.philsimontanzania.org, and register, or you can receive an email if you're already a regular attendee. So we've got some really excellent talks all through the summer and the fall. And we're really pleased that Dr. Patzert and somebody of his caliber has decided to give us a presentation tonight, which is incredibly timely. So Bill is often called the prophet of California climate. He is a distinguished scientist. He trained at Purdue University and then University of California, San Diego Scripps Institute of Oceanography. He is an oceanographer by trade. So if those of us who were previous marine scientists have a particular admiration for that. He had been at JPL. He moved there in 1972 after spending some time in Hawaii doing his doctorate. And he worked at JPL for 35 years, I think, something like that. He has a very distinguished biography and publication list, which if you'd like to have further information about Bill, I'd be happy to provide that with his permission. But he is a very, very respected climatologist. He's often quoted by national and national and local media. He's sort of the go-to guy when we're having weather calamities, and I'm sure he's been pretty busy the last few weeks. He also, of course, has a long list of distinguished awards. Perhaps the most important one is NASA's most prestigious award, which is the NASA Exceptional Public Service Medal. So it is with great pleasure and thanks that I present Dr. William Patzert, and he's going to discuss some climate issues and today's crazy weather. Bill?
Oh, okay. Thank you, Kim, for the inflated introduction. You know, you called me doctor. It reminds me of a story. My grandmother used to introduce me as Dr. Patzert, but she said, but he's not a real doctor. And so I had to live that one down. Well, you know, it's been a lot of weather here in the last 2 to 3 months. But when Kim originally asked me to give this presentation, I suggested we talk about drought. And so I have a little PowerPoint presentation about drought. And I can rush through that and then we could talk about the weather. Anybody has questions, because it's certainly been interesting. But can I share a screen here, Kim, and put up my presentation? Okay, can you see it?
Hi, yes, we can see it just fine.
Okay, great. Okay, so I do a lot of thinking about drought because a winter like this winter is really quite unusual. Uh, Usually here in California, what our experience is long periods of extended drought, of course, punctuated by extremely wild weather occasionally. And of course, this winter it's rain, snow, flooding, tornadoes. It's been an unusual winter, and in many ways, it's been quite welcome. But drought is really our history here in the American West. Many authors, John Steinbeck in East of Eden, he talked about, you know, about the rich years when there were rainfall, but there were plenty of dry years. And those dry years, in some ways, they put more terror in the state of California than the wet years. Now, what causes a drought? Droughts are normal in almost all climatic zones, whether it's wet or dry, warm or cold. And the droughts happen in every US state. Now, common sense will tell you that, a drought is when you have less than normal rain. Question, that's pretty vague. Scientists, they crunch the numbers and they do statistics, and they tell you what the departure is from history. Farmers are very interested in drought, and that can happen in many ways. It can happen through lack of rainfall, or depleting their water supply, or even by the crops that they selected to grow. Here in the urban areas, a drought is when the demand, exceeds the supply, and everybody has to ration their water. In a changing climate, which is warmer and drier, the great forests in the West and here in California, and poor forest management can cause tremendous damage. Over the last few decades, there have been the fatality of more than 150 million trees in the Sierras. And then, of course, there's bad management. We all know about bad management. And that's when you use more water than you have, right? And all of a sudden your reserves start to disappear. And then one of my favorite droughts is what I call a lawyer's drought, right? There's always conflict about water in the American West. And so that's the lawyer's delight, or the legal drought. But in a simplest possible definition, it's really the unsustainable use of our various water supplies. And we do have a great variety of water supplies. But the point I'm going to make here is that most of our present droughts have a huge, not natural footprint, but a human footprint. A lot of these droughts of our own making. Now, this is a drought monitor. It's something that the government puts out once a week, and it tells you across the United States how dry we are. Abnormally dry, or all the way up to exceptional drought. Now, this is our most recent one. This was last week. And you can see that California, Nevada, the American West, it appears to be relatively drought-free. And it hasn't actually, the map has never looked this good. Going back, the last time it looked this good was February of 2020. But where does our water come from? Well, we have two kinds of water. We have imported water and we have local water. And the two sources of our imported water, one is from the Colorado River, and that's where we pump water out of Lake Havasu over the Tehachapis into San Bernardino County, and then we distribute it. That's about 20% of our water. And then in a good year, the great aqueduct that comes down from the Bay Delta and is pumped over the Grapevine, that supplies normally about 40% of our water. Locally, most of the local water comes from groundwater. When the great ice sheets receded, the LA Basin, the Inland Empire, the San Fernando Valley left tremendous deposits of gravel and sand, and they have stored water for centuries and centuries, really thousands of years. And the extraction out of that groundwater is our major local supply. So 60%, this is just on average. You know, there are exceptions here. For instance, San Diego County, which has no groundwater, has 3.6 million people, and they import 95% of their water. It's amazing, isn't it? It's amazing they handed out all those building permits. They have to import, that puts them pretty dependent on the Colorado River and the state aqueduct. Now, here's the little data. The y-axis is inches of rain per year. And the x-axis, of course, is going back to 2000 to the present. And this is for downtown Los Angeles, which is local water in many ways. And so you can see that the average is about 15 inches per year. But for the last 23 years, we've averaged only 12.5 inches, right? So that's 83% of the long-term average. So that's sort of what a drought looks like. It's not zero water, it's not 50% of our water. It's only 17% below the long-term average. And you can see I've put on 2023 here, all right? And you can see it's going to be a pretty good water year, but not spectacular. 2005 was a spectacular year. We had over 37 inches of rain. Now, the other thing that is kind of interesting here is that when you look at the last 23 years, only 7 years have been above average. And so that's what a drought looks like. Now, this is a histogram. Now, you're all scientists, you know what this is. This is the frequency of occurrence of a particular event. In this case, I have bins of 2 inches. And it's kind of an interesting histogram because when you look at what the average is, that's 15 inches a year. In the 145-year record, this only happened 6 times. And so when you talk about average rainfall in LA, it doesn't mean anything because it's bimodal. It's either dry or it's wet, but it's rarely average, right? And the other thing is when you sum it up, below the average and above the average, 6 out of 10 years are below average. So in many ways, drought is normal for Southern California. You know, if you had those odds when you went to Vegas, that 6 out of 10 times you're going to be right. All right, that's pretty good. And you know, I've been making forecasts for the rain year for decades here. And when I don't know what I'm talking about, and somebody asks me what's going to be next year, what do I say? I always say it's going to be dry because 6 out of 10 times I'm going to be right. Now, let's look at imported water. In this case, this is the flow on the Colorado River as it reaches Lake Mead. And the average is is near 15, but it's 15 million acre feet. That's an acre of land 1 foot deep. That's what water people talk about. They talk about acre feet. Right? And this is for the same 23 years as downtown LA. So you can see that the long-term average, about 14.7. But the average for the last 23 years has only been 12.2. Now it's interesting. That's also 17% below average. So that's what a drought looks like on the Colorado River. But that's not the reason Lake Mead is so dry. And so, it is interesting that the drought on the Colorado and the ring around Lake Mead is due to that 17%. But that 17% is like 4 average years. So it's like taking 4 years of water out of the Colorado River over 23 years. And this is also interesting. Of the last 23 years, only 7 years have been above average, much like downtown LA. And so I always use downtown LA or the flow on the Colorado River is sort of my measure of drought in the American West. So the important thing to remember here is that this most recent drought began not 3 years ago, not last year, but it really began 23 years ago. We've been building over 2 decades of drought. So this is what the lake level in Lake Mead looks like. You can see that it was that's above sea level. That's 1,200 feet above sea level, and now it's approaching 1,000 feet. Now, most of that drop happened actually in the first 5 years, 50%. And then in the first 10 years, it was almost 80%. So it happened really between 2000 and 2011. And so for the past 23 years, the average flow on the Colorado River, which is about 15 million acre feet, has decreased by 17%. Now, that doesn't explain why Lake Mead is so low. Because here's the problem, is that the legal allocation that was originally signed in the late 1920s and been revised a couple of times is the 7 states, Mexico, and 7 Indian nations are legally allocated 16 million acre feet per year. So you figure it out. If there's only 12.2 and they're taking 16 million acre feet per year out, you know, either somebody doesn't know how to add or that's gross mismanagement. And so the real depletion and the drop in Lake Mead is not really due to the drought. It's due to the fact that we're taking more out, legally, I might mention, than is coming in. So, you know, there's one way to create a drought. And it's precarious at this point. You know, Lake Mead not only stores water, but it also generates an awful lot of electricity. And it's getting close to what they call dead pool, where it will no longer be able to generate electricity. And that's a problem because a lot of the electricity is used to pump the water out of Lake Havasu into Southern California. And so what I have to say about that is, yikes, what's going on here? Either the guys that manage the water can't add, all right, or the lawyers, you know, definitely have us. Okay, so here to summarize, all right. So we're legally drawing out water from Lake Mead and Lake Powell, almost to dead pool conditions, all right? And if we continue to legally over-allocate that water, Lake Mead and Lake Powell will never refill. And of course, this is a topic of negotiations that are going on right now, and between the various states. And you know, it's like I said, this is a fight on the Colorado River is definitely the lawyer's delight. All right, now let's look at the, what we call the rainfall record here in downtown Los Angeles again, but let's go back to 1945 for the present. Now, from 1945 to about 1978, the average rainfall in downtown LA was about 13 inches, quite a bit below normal, right? And that was a long drought. That was, that was almost a 33-year drought. And then that was followed from 1978 to 1998 with 20 wet years, where the average rainfall was about 17. And recently, our most recent 23 years is 12.4 inches. And so it's interesting. The way I look at it is that we have not years of drought, but decades of drought. So it's dry, it's wet, it's dry. And if you look back in the historical record for centuries, this is a pattern we've always seen, these what I call decades of drought. Now, another interesting thing about this is that we have what I call frequent 5-year episodic droughts. And you can see they're called off here in the late 40s, right? In the late 50s, and even in the very wet period here in mid-1980s, we had a 5-year drought. And the one we had most recently, like 2011 to 2016, the average rainfall in downtown LA was only 8 inches for a 5-year period on average. So that was a serious drought. That was half our normal rainfall, right? So the point I want to make here is droughts are long. Right? They're not just 1-year events, but they can be decadal events. And these 5-year droughts, which can be quite punishing, are really quite common when you look back in the record. As I mentioned here, 2012 to 2016, we had a total of only 39 inches of rain for 5 years. So that was half our average rainfall. And you'll notice that during that period in the 50s, and also in the 40s, we had these 5-year droughts. And then there was a very dry period there at the end of the 19th century where we had these 5-year droughts. And so this was the driest 5 years in the historical record, which goes back to 1878. Now, the other thing about the droughts, I showed you the drought monitor right at the beginning, which is a measure of drought. And this is for California. This is the drought monitor for California for the entire state. And it begins in the year 2000. And then you see we have these dry 5 years, then we get a wet year, dry 5 years. But as it goes on, it gets drier, a wet year. And then the driest 5 years, which is the 5-year record that I showed you in the previous slide. And it's wet, it's dry, it's wet. And this is our most recent 3-year droughts. So the interesting thing about droughts is that you're in, you're out, you're in, but the longer they go, the more punishing they become. So droughts are not only long, but they wax and they wane. And then here's the drought monitor for last summer, in contrast with the one I showed earlier. And you can see that California and the American West, even into Texas and all over the Southwest here, we were in extreme to exceptional drought. And so their droughts are long, they wax and they wane, and they're large. And so this is the most recent drought monitor, all right? So in 7 months, all right, all of a sudden the drought disappeared. But did it really disappear? Did the real drought disappear? Because this is just a meteorological drought. This doesn't tell you anything about Lake Mead or Lake Powell or the groundwater supplies. Now, I took the top picture with my Brownie in 1900. You know, I've been at this for a long time. Then I went back and used my iPhone to take another picture from Mount Wilson looking out at LA. And what a difference, huh? Now, we've had tremendous growth in California. In 1900, there were only 1.5 million people in California. In 1950, there were only 10 million. Today, there are 40 million. And so, in a semi-arid region like we live, and this is semi-arid, all right, growth creates drought because it creates tremendous demand for natural resources and especially water. So at some level, this tremendous, and you can see, for instance, California's growth rate is definitely much more rapid. It's 5 times larger than the world population growth rate. So people love California. So when you talk about drought, you have to talk about everybody. All this tremendous growth that we've had, not only in population, but in industry and agriculture. California all by itself is the 4th largest economy in the world. It has a larger economy than Russia. And all that demand for water and all, you know, I always say is that water equals affluence. And there's been a tremendous growth in affluence, for instance, in California in the last 50 years. Now, here's another way to create drought, is that in the early part of the 20th century, 19th century, we had tremendous floods in Southern California, really from the mountain and the San Gabriel Valley communities all the way to Long Beach. Los Angeles is one great big floodplain. If you just close your eyes and think about it, it's a giant floodplain is what it really is. And we've had in the 1930s tremendous floods in 1934, 1938. We had 8 inches of rain in one day, and half of that's when the LA River ran free. And for 2 to 3 miles on both sides of the LA River, south of downtown LA, everything was underwater, tremendous damage. And so we decided in conjunction with the Corps of Engineers that it was time for some flood control. Well, what they did is they concreted all the rivers to move the water as rapidly through LA County, Orange County, as they possibly could. They concreted the river. So the LA, quote, river is 51 miles long from the San Fernando Valley all the way to Long Beach. And it's connected to 6,500 miles of storm sewers, right? 48 pumping stations. And of course, it serves 4 million residents. In other words, it keeps them out of the floodplain. Now, we did the same thing with the San Gabriel and the Santa Anita River. Okay, so that was a decision we made to go for flood control, not water capture, because there's literally billions of gallons of water flowing down the LA River as we sit here this evening. Okay, so what happens, all right? So essentially what happens is that all the garbage and all the storm sewers, it all makes its way down and dumps, you know, right by the port of Los Angeles, right by the Aquarium of the Pacific there. And so 85 to 90% of the water that falls in Southern California, we don't save it. It ends up in the ocean, sleeps with the fishes, all right? And that was a decision we made in 1938 when the population of Southern California was more like 3 million rather than 20 million. So, let's get right down to it. Most of this rain, in terms of our water supply is just wasted because we opted for the flood control. And so this is what I call a concrete drought, all right? Is that what a tremendous opportunity was lost. Now, there's another, I said our main source of local water are groundwater basins. When the great ice sheets receded 10,000 years ago, is they put tremendous deposits of sand and gravel in the LA Basin, Inland Empire, San Fernando Valley. And so we're sitting on great water basins. I mean, great water basins. One of them is the water basin here in Pasadena. And you can see that for the past century or more, we've been drawing down the water in that basin called the Raymond Basin, all right? Supplies half of Pasadena's water supply, and it's disappearing. So there's been a drop from 325 feet in the past century. And so the question is that should we replenish some of the water in this basin, or should we just keep drawing it down until all of a sudden we have the same situation we do in Lake Mead? And so this is another way to create a drought. Right? Half of our water supply is continuously been drawn down for the past century. So this is what I call the invisible drought, because nobody knows it's there, even though most of your water supply is coming from beneath your house. Here's another example of the same thing. This is one of the wells in the Raymond Basin. This is near Sierra Madre in the San Gabriel Valley. And you can see the same thing happens. We do put some water in this particular well. That's the black is the blue line. That's Colorado River water. But you can see here since the last big El Nino, that first very dry 5 years of the present drought, see how it's dropped? Then you get a couple of wet years and then it drops. So it waxes and wanes, a lot like the drought monitor does. And of course, this was the driest 5 years ever. So this is what it would look like if we didn't put this water in. But the bottom line is still the same. The groundwater in that well has dropped 80 feet in the past 26 years. So the question is, how low can you go? Now, the greatest supply of water in California is in the San Joaquin Valley, because this is where, when the great glaciers receded and melted, they left deep, huge water supplies in the San Joaquin Valley. And this was called what we call an aquifer. Now, aquifers are deep in contrast with groundwater. Groundwater can be replenished every year. Aquifer water is 10,000 years old. This is fossil water. And we've drilled the San Joaquin Valley literally with hundreds of thousands of wells. And so in some places we've drilled it so much, the land is subsiding. Not a few feet, but in some places 30, 40, 50 feet. And it just shows you here, for instance, from 1962, that how much water we've taken out of the aquifers in the southern San Joaquin Basin. And so over 62 years, that's over 50 years, we've taken 80 million acre feet out of those aquifers. This is not only true, by the way, of the San Joaquin Valley, this is a problem all over the world. So the valley itself is drilled by over 100,000 wells, and basically it's unregulated, it's unmetered. You know, in many places in Central and Northern California, they don't even have water meters. They just go for it. But, you know, 80 years ago, you could drill water from 100 or 200 feet. But now the only people that really have access to that water are the industrial agricultural companies. And today, they're drilling wells at over 1,000 feet. And each of those wells costs $500,000 each. And so there's the death of the mom and pop firm, because only these large industrial agricultural companies can afford to drill those kind of wells. And the real question is, again, how low can you go? You know, because you know, this is essentially what has sustained California agriculture for the last century or more. And what you see is, for instance, this is a recent count of how many in the Central Valley, how many wells have gone dry, all right? Our households per county where they have dry wells. And you know, small communities and small farmers literally no longer have access to water. All right. So again, I emphasize that California agriculture is sustained by the overpumping. All right. And by the way, when it rains, the aquifers don't get refreshed because they're too deep. This is water that's 10,000 years old. And once it's gone, it's gone. All right, so the aquifers and the groundwater basins, you know, they're the invisible drought, but they're really your 401k. All right. And so the question is how low can you go on the aquifers and the groundwater basins? They're going dry. When they go dry, they sink. And when they sink, they disappear. So they're really no longer available. You actually can't pump water back into those reservoirs and groundwater basins once they start sinking. And so when it's gone forever. Now I'll just talk about my favorite kind of drought. It's what I call the global heating drought. Now there's no doubt that the climate is changing. We're living in a warmer world. The great ice sheets are melting, and of course, the unequivocal proof is what I spent my career doing, is measuring rising sea level. And as an old surfer, I can tell you that the beaches are definitely disappearing. And so this is no longer a topic of dispute or discussion. This is a scientific fact, and it's baked in for at least the next 50 to 100 years. So looking into the future, a higher, hotter, and drier West is guaranteed. And so this is what I call the climate change drought. And, you know, the average temperature in Los Angeles, annual temperature, is 5 degrees Fahrenheit warmer than it was 60 years ago. And in September and October are our hottest months. Here in the San Gabriel Valley, the average temperature is 8 to 9 degrees Fahrenheit warmer than it was 60 years ago. And of course, the hero of that story is Willis Carrier. Anybody know who Willis was? Well, Willis invented the modern air conditioner. So as we look out into the not far future, but near future, without air conditioning, much of inland Southern California is going to be close to unlivable, right? And it definitely will be creating a drought. So, you know, the hydrology, that's the rainfall, the snowpack, the groundwater, in the 20th century is not going to be what we see in the 21st century. And so we're going to have to do a tremendous evolution in our thinking and huge adaptations with regard to our water supply. That's my quote for this week. Now, who consumes California water? Now, the California water, some of it has to go to the environment to maintain, for instance, the great Bay Delta and some of our fisheries, like the salmon fishery and the rivers. And then 50% of it goes to ranchers and agriculture, and the urban and industrial users get about 15%. So this is not a good way to look at it. That's the gross. So the net, since 35% of it is essentially unavailable for use by agriculture or urban users, ag gets 80%, urban users get 20%. All right. And so how agriculture uses their 80% has a huge impact on drought. Now, let's go look at the who's who of California water. Again, environmental 35%, urban industrial 13%, agriculture, all right? And so we use about 65 million acre feet of water per year in the state of California. That's a lot, 65 million acre feet. But the real available water split is most goes to agriculture, 20% goes to urban. Now that's probably generous, because when you consider all the water that agriculture is drilling out of the San Joaquin Valley, it's more like agriculture gets 90% of the available water and the urban industrial users only get about 10%. And so here's what I call the infinite aquifer myth that creates drought. We keep drilling those aquifers to death. We have for, not just 10 years. We've done this for more than a century, right? And the large agricultural corporations, they don't seem to care. They can afford $500,000 wells that go down 1,000 feet, all right? But essentially what they're doing is they're like in Lake Mead and Lake Powell, we're overdrafting all these aquifers at an increasing rate, right? NASA measured, from space, we actually measured over that 5-year drought period. There were 8 million, the total was 8 million acre feet of water per year was taken out of the San Joaquin Valley, and nothing was going back in. Now that was a record, but of course that was a record 5 years. So the bottom line is ag is the 800-pound gorilla of California water usage. They get 90% of the available water, all right? Now here's an irony. It turns out that California is the 4th largest economy in the world, but agriculture is only 2% of California's economy. Of course, they provided a tremendous amount of agricultural product, not only for California, but for the nation and other nations. But it's only 2% of the California economy. But they have the largest presence in Sacramento. 2 largest lobbying groups in Sacramento are agriculture and oil. Interesting, huh? Now, why, of course, we're the largest agricultural state, and we're the 3rd largest oil producing state. And, but that's a different talk, all right? So where does it come from again? The State Water Project, Colorado River imports our water, and then 40% of it is local, all right? And the drought monitor, which looked so good last week because of all our recent storms, right, omits the groundwater in the Colorado River, which supplies 50% of our water supply. So I contend we're definitely not out of a drought. Now, how do we fix all this? Now, I love this quote, you see the obvious things. The obvious thing would be to turn off all the fountains of the Bellagio and stop selling alfalfa that we grow in the Imperial Valley to China, and, close down all the golf courses in Palm Springs. There's 123 golf courses in Palm Springs. Can you imagine that? And each of those golf courses takes 300 million gallons of water per year just to maintain it. All that's just one. All right. And of course, we all know about the almonds. And of course, the one I like the best is what's happening on the Colorado River. That's the lawyer's drought. But these are all great ideas, but that's not enough. You know, in the 21st century, we're going to have to adapt to global warming or global heating. It's the real deal. It's a scientific fact. It's built in for at least the next 50 years as we try to transition from fossil fuels to renewable energy. And the other thing is, you know, you have to think about how we manage the aquifer water. We can't just drill it down until we hit bottom, right? And we concreted all the rivers, but we have to think of how, when we have these big storm events like we did this winter, how we can capture that water, how we can clean up a lot of the groundwater basins. And we have to use more groundwater. That means more local supply. Another thing to think about is a fair use of all our diverse water sources. You know, is it fair that the farmers get 90% of the water? You know, if the farmers were 10% more efficient over the last 20 years, nobody in LA would have had to take out their lawn, right? And then another big problem is infrastructure. A lot of our, you know, everybody remains, Lake Oroville. Remember the spillway at Lake Oroville 5 years ago? A lot of our infrastructure is falling apart, that both for flood control and for transporting and moving water up and down the state. And the other thing is that, and this, we all know this, and everybody's making, we have to be more efficient. Everybody has to conserve more water, but mostly agriculture. You know, this flood farming for rice and alfalfa, you know, that's very, very water inefficient, right? And now we're thinking about things like wastewater recycling, which we're already doing, actually. Orange County has the largest wastewater recycling plant, that's toilet to tap, in North and South America. They do 1 million gallons of water per day, and the water is cleaner than Colorado River water or the water that comes down from the Bay Delta. And a big one is, I just hate to watch the LA River, all that water going down and passing by the aquarium of the Pacific. This is a big problem, expensive problem, but we have to capture stormwater. As you know, little things like rain barrels, but large things like diverting, you know, the LA River and the catchment basins. And people are even talking about desalination now. You know, San Diego County has the largest desal plant in North America, in Carlsbad. It's expensive, but, you know, we might have to think about that, right? You know, it's a, so here's my point, is that in many ways, drought in California is mostly human cost, you know? It's not like money, you can't print it. There's a finite amount of water and that amount is shrinking. And so we've got to do a much better job of managing what we've got. And this is America. The way you do that in America, like any big project, you have to legislate it. It's not everybody will agree and do their small part. It has to be legislated, has to be enforced. And of course, in the end, it will always be litigated. So water is a tremendous jobs program for lawyers. So when you legislate, you enforce, you litigate, what does that mean? If you want a livable California with enough water for everybody, we have to vote smarter, all right? We can't let the oil and the agricultural lobby dominate the water laws, not only in Sacramento, but also in Washington, D.C. So be careful who you vote for. And that's it. I told you more than I know. Let's talk about the weather.
Well, thank you very much, Bill. That was really a concise way of looking at, and an interesting way of looking at things. And I had a couple of questions, and since I'm the host, I'm going to take advantage of that. First, I would encourage people, if you have a question, to put it in the chat room, and we will try to get Dr. Patzert to answer it as best he can. You know, this project that we have is in East Africa, and they, of course, have been experiencing tremendous drought as well, and have many perhaps similar patterns in terms of the sort of cyclical nature of drought and too much rain. What kind of things can we do if California sets the example for the rest of the world on how to monitor and preserve our water resources, and how could that be transferable to underserved countries that may lack significant infrastructure and so forth? Can you see any avenues towards that?
Well, you know, California is known for its innovation. And let's take, you know, we're semi-arid, but there are even drier countries than the United States. Israel, for instance, they use 50 gallons of water per day per person. Australia uses 80 gallons per day per person. We use 160 gallons per day per person, all right? And in Australia and Israel, they've developed a tremendous water efficiency engineering industry. And to me, it seems a no-brainer that California, in many ways, with all the diversity we have and different water uses, we should be leading, venture capitalists should be pouring money into water efficiency, which we can export throughout the world. Water is a big problem, not only in California, but everywhere, especially in some of the undeveloped nations, in Africa, in the Middle East. And so, you know, I think, you know, we have to provide the leadership for that kind of thing.
Yeah, I would agree with you on that. And I think that, you know, the saying goes is that you can go 3 weeks without any food, but you can only go 3 days without any water. The human body is not geared to really survive prolonged periods of no water. And I think that speaks to the issues that so many countries have. In Tanzania, for example, a lot of the women carry the water on their heads. And, you know, these are 50-gallon buckets they're carrying on top of their heads, and that leads to all kinds of arthritic changes and so forth in their neck. And it's a pretty problematic way of transporting water. But I think it behooves the resourced countries to develop techniques to preserve water. I think that can do with an appropriate verb spill over into the smaller nations that really don't have access to that for environmental reasons and human reasons, obviously. One of the questions we have is why desalination is not considered to a larger scale or earlier. Is the water not our main priority, and are we just being ignorant?
Well, the problem with desalination is cost, because it takes a tremendous amount of energy to take ocean water and desal it. And then once you've desaled it, the problem is that all the customers are uphill. So then you have to pump it uphill. So if you desal it in Long Beach and you have to pump it to Pasadena, so the cost of desal water is 4 to 5 times of what I call state water or Colorado River water is. So the primary problem, there are some environmental concerns as well, but the primary concern here is cost.
And then someone asked, what is a reasonable target of consumption per day for a Los Angeles resident?
Oh, I think we could easily reach 80 gallons per day per person. And compare that with countries like Tanzania, where people don't have 1 gallon per day per person.
Right, right.
But you know, if your yard plumbing, you know, was in your house, you'd be living in 6 feet of mold. So one thing, a simple thing you can do is just check your outdoor plumbing system.
And then I was thinking when you were talking about the tapping in deeper and deeper into these really deep aquifers, is there any data, maybe this is a question for your seismic comrades at NASA and Caltech, but is there any evidence that that kind of sucking the water out increases the risk for seismic activity? I know that
I'm not
fracking does.
an expert on that, all right? But I haven't heard any evidence for that. You know, actually, there is some evidence. You've seen it in the oil industry. When they pump underground,
Yeah,
in places like Oklahoma, where apparently it does generate earthquake activity. All right?
yeah, it's just something else to worry about.
It would make sense with water too, because these are tremendous volumes that are being in cavities that are being created, and subsidence. You know, there is measurable subsidence. I said the groundwater basins are being drained in the San Gabriel Valley. You know, you can actually measure the subsidence in inches and feet in the San Gabriel Valley, and it actually causes damage to the infrastructure, the sewer system, the water delivery system.
Do you think, as an oceanographer, that we can rely on the La Nina and El Nino patterns in terms of predicting weather, or do you think that because of ocean warming that those are sort of irrelevant, or we need to come up with new parameters?
Well, nobody really knows, but the largest signal in the climate system is still the annual signal. You know, as the sun shifts from northern hemisphere to southern hemisphere, and it's a tremendous redistribution of heating in the two hemispheres. And of course, the evolution of all life on Earth is coupled to that annual signal in the climate. But after that, it's the El Nino and the La Nina, which are these big changes in the temperature in the tropics. And they have a powerful impact all over the globe. Now, what global heating does to those natural climate variabilities is an uncertainty at this point. Some people say more El Niños, some people say more La Niñas.
Do you think that I think there was a lot of prediction that this was going to be a La Nina year, and that doesn't appear to be the case, judging by what's happened so far. That's sort of why I asked the question: are there other parameters that we need to make to design to better assess water and rain patterns in the setting of climate change?
Well, you know, you're all people that have to diagnose diseases and how they proceed, and the El Nino and the La Nina are like that. They're a seasonal forecast that's months to years in advance, in contrast with the 7-day weather forecast, which, by the way, is excellent due to the advent of satellites. But a statistical forecast like an El Nino and a La Nina, they're only right 7 out of 10 times. And so many climatologists have stubbed their toe on making a dry forecast for a La Nina, like this winter, for instance. And so, you know, it's statistics. It's not science. You know, they always say the last refuge of all true scoundrels, whether they be medical doctors or climate doctors, is statistics.
There's some truth to that, that's for sure. Speaking of a medical scoundrel, here's one from a physician. In terms of local legislation, what intervention should we be advocating for? And what kind of immediate provisions and revisions should we be pushing our local councils to institute?
Well, we do have new laws that have been passed, but they haven't been instituted yet to regulate the groundwater supplies and the aquifer supplies. And this was long overdue, but I think it's not going to be implemented and enforced at least for another decade. And it should be today, right now, because I think it's the thing like with Lake Mead and Lake Powell. I mean, that's ridiculous. For 23 years, there's been 2 million acre feet of water coming down the Colorado River. And we've been taking 16 million acre feet out of the Colorado just because we signed a treaty in 1926, you know? That's, that's bad addition or worse management. And so somehow, by the way, this all should have been enforced by the federal government, but they've been dragging their feet on it. But what a tragedy that would be if Lake Mead goes to death pool, which if I was a betting man, which I am, I'm betting it will.
Mm. So another question, do you see any problem with carbon capture and sequestration of carbon dioxide interfering with aquifers? CCS is what the oil lobby is pushing to keep drilling.
Okay, I'll give you a simple answer. I think carbon capture is a hoax. All right. It is funded by the federal government and other agencies. And most of the research is being done by the oil companies. And it just doesn't scale up. It's expensive, it's small scale, it's trivial compared to what's required. And what it really, I think of the intention of the oil companies with carbon capture is just to slow down the transition to renewable energy. So I'm strongly opposed to carbon capture. Basically, it doesn't work where it's been tried, and it's expensive.
Right.
All right. But your question's a good question. If you capture it, what do you do with it? It's like nuclear energy. It sounds good. All the nuclear waste is, we created a monster with nuclear energy.
Dr. DeVolio is making a comment complimenting the choice of your topic, and that there's hope for the future if we understand our future is in water efficiency. And I would certainly echo that. And then one final question that I have is, can you explain what is a bomb cyclone?
Oh, that's interesting. A bomb cyclone. All right. Is that, we have recently the pattern has been this talk of atmospheric rivers. And these are large plumes that develop in the tropics and the subtropics, where the air and the water is much, much warmer. And so the atmosphere holds more moisture. And as these plumes move northward, the moisture starts to condense. And often these long plumes, they can be almost 1,000 miles long and a couple of 100 miles wide. So they literally look like rivers in the atmosphere. When they merge with these very cold, intense, low pressure systems out of the Gulf of Alaska, these atmospheric rivers will start to hose down California, starting in the north, the central, and eventually here in the Southern California. But when these low pressure systems meet the atmospheric rivers, sometimes they intensify the low pressure system, the strength of the storm, and the pressure within the system drops precipitously, literally over hours, not days or weeks, all right? And that's called a bomb cyclone. So all of a sudden, the winds start to intensify because the pressure drops, and you can go from winds of 30, 40 miles an hour to winds of over 100 miles an hour, because it almost looks like a hurricane. So it's the bomb cyclone is the rapid intensification of the low pressure in these storms that come out of the Gulf of Alaska.
Well, that's just been fascinating. We could go on with this for hours, I think, but I just want to thank you for taking the time to share your wisdom and wealth of information with us, Bill. And on behalf of everybody who attended tonight in the Phil Simon Clinic Tanzania project, we really thank you very much for giving us some enlightenment about our Earth, and at a very timely time. And hopefully we won't have a bomb cyclone tonight. So.
The Northern California and Central California have really taken the brunt of the punishment here in the last 3 months. Actually, except for all the snow in the local mountains, we got off pretty light because, you know, like I said, we've invested billions of dollars in flood control here in Southern California. So it's been exciting, but it hadn't been that bad in Southern California yet. It was a kind of a shocker after all those dry years, you know.
I think everybody enjoyed it for a while, and now we're kind of sick of it. So it's not good when we surpass Seattle in terms of the amount of rain we've had. So
No, I just wanted to say one thing before we sign off here. I wanted to express my admiration for all the work that you and all your friends and colleagues have done in Tanzania in dealing with infectious diseases. It's remarkable work, and you know, I think I'm going to have to join you one of these trips.
you would be very welcome.
You probably, you know, with all you hotshot doctors, you know, you probably, you know, you probably need a strong back and a small mind, you know.
We've got a few of those already, but that's certainly something we need. And it's always nice to travel with us, because when there's a medical emergency, you have an entire hospital with you. So, which happens sometimes on the airplane flight over. So we've had to do that a few times. KLM comes on and says, "Is there a doctor on board?" And he said, "Sir, you have an entire hospital on board. Would you like some plastic surgery done while we were in the area?" So
No, Tanzania has, you know, it's in terms of water, it's really feast or famine, and the whole ecosystem is driven by you know, the great migrations over the Serengeti every year between drought and the monsoon floods, and you know, the water infrastructure compared to a place like California. You know, the only reason LA exists is because of Lake Mead, you know, all the water we stole out of the Owens Valley, the State Water Project. You know, there's never been a place that had so much water infrastructure as California. It's remarkable that 40 million people live here in a semi-arid environment. But these countries in East Africa and Central Africa, there's almost no water infrastructure. You know, it's really what a harsh place to live.
it's true. And I think some of our attendees tonight are veterinarians and interested in the One Health Project and how intertwined all living things are on the planet, and dependent on maintaining the health of the planet itself, its resources, and so forth. And so I think that's a perfect segue into our next speaker next month. I'd like to thank everybody for attending tonight. Please tell your friends and colleagues about this project and about the series that we have, because it's a nice thing to do on a rainy Wednesday evening. And you really have access to some brilliant minds like we did tonight with Dr. Patzert. So I want to thank him again for taking the time to spend with us and give us his information.
Know that